No, sir.
Okay, fine. Right, last class it was all about Wheatstone bridge, balanced, unbalanced, how to solve. Okay. Fine. Let us now discuss about bulbs and circuits having bulbs in them. And after that, we will talk about an instrument called meter bridge. Okay. So, Seshank, tell me, how does a filament bulb work?
When current flows through it,
Hmm.
the filament inside the bulb gets heated up, which produces light.
A filament inside the bulb gets heated up and then
Due to the heat, it glows and produces light.
okay, due to the heat, that filament metal that is there, okay, it starts radiating light. Okay, fine. So it will immediately attain a high temperature and start radiating light. So we discussed this concept when a current I passes through a resistance R. Tell me, how much is the power dissipated by it? How do you calculate power dissipated by it?
I square R.
I square R, correct. Fine. Now, power by definition is rate of transfer of energy, you can say rate of release of energy. Fine. So you can write this as dH by dt, the rate at which heat is dissipated. Okay, because when current flows through a resistor, the energy that is released is heat itself. Okay. So you can write dH is equal to P dt, that is I square R dt, and the total heat dissipated in a particular interval will be integral dH, that becomes integral I square R dt. Fine. So basically a bulb works based on this idea itself. When current passes through a resistance, heat is generated. And we discussed this in the last class also, or last class or the class before this. Bulb is basically a resistance. Fine. This is the standard circuit symbol for a bulb. And have any of you seen a filament bulb? Like, have any of you noticed what is written on a bulb? These days, mostly those bulbs are not even used. Even if it's an LED bulb or CFL, okay? Have any of you written the specifications mentioned on a bulb? Sorry, read the specifications mentioned on a bulb? Or if you want to purchase a bulb, what do you look for? Price is one thing, definitely. What else? Isha, have you ever seen what is written on a bulb? At least the box.
No, sir.
Okay, fine. Shashank, what about you?
The wattage.
Okay, yeah. On a bulb, the wattage will be written. Like maybe these days, like LED CFL bulbs, you will have like 9 watt, 12 watt. Fine. Uh, those filament bulbs that we used to, I mean, they are still there, they're still used. The filament bulbs, usually their wattage is high. Okay. 60 watts, 100 watts. Okay. So a wattage will be written on it, correct? You can call it wattage, or it's actually called the power rating of the bulb. You can also call it as a rated power of a bulb. Okay. Suppose there is this 60 watts written on a bulb, or suppose you buy an LED bulb and 9 watts is written on it. What does this mean? Or what does this value suggest? Anyone?
The maximum power the filament can withstand.
The maximum power
It can withstand.
it can withstand, kind of, yes. See, the power rating of a bulb, not just a bulb, any electrical or electronic device that you take will have a power rating on it. Okay, this is the maximum power that it can consume from the circuit. Okay, this is not the power output of the device, it is the power input of the device, how much power it can consume at most. That is the power rating or the rated power. So you should ensure that when this device is placed in the circuit, the power consumed by it does not exceed this value. Okay, you have to choose the resistors, capacitors, or you have to arrange the circuit in such a way that this device does not consume more power than the rated power. Okay, we'll solve problems, you'll understand what it means. Okay, anything else you noticed written on the bulb? Not just a bulb, any electrical or electronic device you take, there will be some specifications on them. Have any of you noticed any of them? See, for every device, okay, there will be a rated voltage also. Okay, usually for the devices that we use here in India, it will be around 220 volt. Okay, this is the rated voltage. Any idea what this means or what this value suggests?
The sockets in our homes provide a potential difference of 220.
Can you repeat? It was not clear.
The sockets, the power sockets in our homes provide a potential difference of 220.
Okay, but on a device it is written 220. What does that mean? On sockets, if they write 220, that means the socket can provide a voltage of 220. That's fine. What does the 220 on a device mean? And if you see devices imported from US, okay, or if you see the devices which they use there, for them, I think it is around 110 volts. US or UK, I don't remember. They use 110 volts. What do these numbers suggest? Okay, see, rated power is the maximum power that a device can consume. Okay, can withstand also, you can say. Similarly, this voltage, the rated voltage of a device, is the maximum safe voltage at which you can operate the device. You should ensure that the voltage given to it does not exceed this value. Fine. And now suppose there is a bulb which is rated like this, 100 watt, 200 volts. Okay, suppose there's a bulb with these values written on it. That means you should not apply a voltage more than 200 volts across that bulb. And when 200 volts is applied, see, rated power and rated voltage are connected. This is the power, this is the maximum power, this is the maximum voltage, right? When will the device consume maximum power? When the voltage given to it is maximum. Okay, we know power is equal to V square divided by R. So when the voltage you supply increases, the power consumed by it also increases. Fine. So the heat produced will increase. But if you supply too much voltage, too much heat will get produced and the device will not be, the materials in the device will not be able to withstand it. Okay, it will malfunction or it may get short circuited. Anything could happen. We cannot say. Okay. So rated power is the maximum power it can consume. Rated voltage is the maximum voltage that you can apply. Okay. And you will see it consuming maximum power when the maximum voltage is applied. They are related that way. Okay, so if you know the rated power and the rated voltage of a device, okay, be it a bulb or any device, you can tell the resistance of the circuit inside. Okay, let us stick to bulbs itself. As I told you, bulb, the filament in a bulb, it has some resistance, right? So you can find out the resistance. R becomes V square divided by P. So 200 square divided by the power dissipated when the voltage is 200 is 100 watts. So that way you can tell the resistance of that bulb. And then you can solve questions like you'll be asked something else about the circuit. How much extra resistance should be placed to operate this bulb safely, such things. Once you find out the resistance of the bulb, you can consider it as a normal circuit having resistors and batteries and tell the voltages. Okay. So remember, effectively, bulb is a resistance. When a voltage is applied across it, it dissipates power. So on the bulb, they will specify maximum power and maximum voltage. From the maximum power, maximum voltage, you can derive the resistance. Right? Okay. What happens if you apply more than the rated voltage? Too much power will get generated, means too much heat will get generated. The bulb, like the filament will melt. Okay, it will break and the bulb won't glow anymore. But tell me, what do you think happens if we apply a voltage less than the rated voltage? Suppose a bulb is rated 100 watt, 200 volt, but let's say you supplied 100 volts to it. What happens to the bulb?
It doesn't glow as brightly as it can.
Okay, so you're saying it will glow, but not as bright as when it glows with 200 volts. Okay. Isha, what do you think?
Yes, sir. Same.
Okay, fine. That is correct. It will still dissipate power, but not as much as it dissipates at 200 volt at the rated voltage. Okay, so you can operate devices at a voltage less than the rated voltage, but not more than that. Fine. Try this question. Suppose there's a bulb rated 100 watt, 200 volt itself. Now, if you apply a voltage more than 200 volt to it, we know it will get fused. Okay, getting fused means too much current passing through a wire that the wire melts due to the heat. That is what we call as getting fused. Fine. So if more than 200 volt is applied, it will get fused. Suppose we have a supply, voltage supply of 300 volts. Now we know we can't connect this directly to the bulb, it will get fused. But suppose you want the bulb to glow using this voltage. You want to make it function using this voltage. Tell me what can be done. We have a 300 volt source, 200 volt bulb, but we want the bulb to work safely. What can be done? Okay. The source voltage is 300. Bulb can only withstand up to 200. Means we have to distribute the voltage. So we need to add some extra elements in the circuit. Okay. And we know bulb is a resistance. It has some resistance. Both of you quickly calculate the resistance of this bulb.
400.
How much? Okay. R is equal to V square divided by P. 200 into 200 divided by 100 becomes 400 ohms. That's the resistance of that bulb. Okay. Now the voltage, this voltage of the supply is 300. Out of 300, we have to ensure that this bulb gets 200 volts, not more than that. Means the other 100 should be shared with some other element. Okay. Let's say you have to connect a resistance here. Tell me, how much resistance will you take? First of all, are you both convinced that this way we can make the bulb work safely or not? by adding some extra resistance and distributing the voltage. Is it possible to make it function safely or not?
Yes, sir.
We can. Okay. So now tell me, how much additional resistance should be included in the circuit to make the bulb function safely? Okay. Look at the circuit given here. The bulb's resistance and the additional resistance, how are they connected?
Series.
They are in series, correct. When two resistors are in series, what is common for the resistors? Current will be common. Okay, not just resistors. Any set of elements connected in series will all have the same current passing through them. Okay. Then tell me, voltage across the first resistor will be IR1 and voltage across the second resistor will be IR2. What is the ratio of voltages? I gets cancelled. It is R1 is to R2. We had discussed this before also. Okay. Now we want the voltage 300 to get distributed as 200 and 100. Means in the ratio 2 is to 1. That's all. Based on that, you all tell me how much resistance should be taken here. How much additional resistance should be connected.
200.
That's all. Ratio should be R1 is to R2, 2 is to 1. This is 400 ohms, then this should be 200 ohms. That's all. So if we connect an additional 200 ohm resistance, this bulb can be operated safely. What if we connect more than 200 ohms? Okay, I think I'm mixing up ohms and volts. Anyway, let it be. What if we connect more than 200 ohms?
The bulb doesn't get its optimum voltage.
The bulb doesn't get.
Its optimal voltage.
See, if the bulb gets a voltage of 200, then it will consume a power of 100 watts. And in that case, it will glow the brightest. I mean, it's best glow you can get. But if you increase the other resistance beyond 200, then the ratio will become less than 2 is to 1. 400, 200 ratio is 2 is to 1. But if the other resistance is increasing, then the ratio decreases. Then the voltage share of the bulb will decrease. The bulb will not get 200 volts. And if the bulb doesn't get 200 volts, it cannot consume 100 watts. It won't glow as bright as possible. Okay. It won't give out its best possible brightness. That's all. It will still function. Okay. And also remember, 100 watts here is the power consumed by the bulb. It's the rate at which it consumes electrical energy. Now, bulb is a device which converts electrical energy to light energy, right? It consumes 100 joules of electrical energy per second. That is what 100 watt means. It is not necessary that it gives out 100 joules of light energy per second. Okay. In an ideal case, when the efficiency of conversion is 100%, all the energy consumed by the bulb, all the electrical energy consumed by the bulb will get converted to light. Then you will see an output of 100 watts. Okay. For now, we will assume they are ideal bulbs. All the heat is converted to light. Okay. This time, assume the supply voltage is 200. Let's say this is a bulb rated 50 watts, 200 volts. and this is rated 100 watts, 200 volts. Okay. Let's call the bulbs as B1 and B2. Find out which bulb glows brighter.
B2 glows brighter.
Okay, Shashank, you are saying B2. How did you conclude that B2 glows brighter?
It has a lesser resistance than B1, so lesser resistance means more current flow.
Lesser resistance means more current when equal voltage is supplied. Here, there is no guarantee that they will get equal voltage. Okay. You are using V is equal to IR to tell that lesser the resistance, greater the current flowing through it. But still, see, power is, if you want, I mean, if you are answering in terms of current and resistance, it is I square R. Resistance is less, current is more, but it's the product that you need to find out, no? I square R. So who knows? And also, yeah, as you said, not as you said, what you said was less resistance, more current. That is when they get equal voltage. Here, there's no guarantee of that. Any other idea, anyone? Okay, first of all, tell me, will both the bulbs glow safely or not? You look at their rated voltages, you look at the supplied voltage. Are they safe or not?
Yes.
Okay. See, the supply voltage is 200 and their rated voltages are also 200, 200. They are connected in series. When resistors are connected in series, the voltage gets distributed. Okay, so no bulb is going to get all the 200 volts directly. They will get a lesser share itself. So both will operate safely. That's fine. Okay. Now, the question is only to find out which bulb glows brighter. How to proceed? Any idea?
Sir, I found V1 is to V2.
Okay, you found the voltage ratio. How did you find the voltage ratio? Good, that is a reasonable method.
Sir, first resistance I
Huh.
found, and V1 is to V2 is equals to R1 is to R2.
Okay, R is V square by P. So how much is the first resistance that you got?
800.
Becomes 800 ohms, correct. Second bulb's resistance.
400.
Good. 400 ohms. Okay, so resistance ratio is 800, 400, that is 2:1. Then the
Yes.
voltage ratio will also be 2:1. So how much is the voltage across the first bulb? Like you have to split 200 in the ratio 2:1. See, this is simple mathematics only. If you have to divide or if you have to split a number in a certain ratio, like here 2:1. 2:1 means 2 parts to one of them and 1 part to the other one. So totally how many parts have it has to be divided into 3 parts. So first the ratio that you have, add it up. Okay, 2:1, 2 plus 1 is 3. Divide 200 by 3, that is 1 part. And 2 parts of that you have to give to the first bulb. So 2 into 200 by 3. 1 part of that you have to give to the second bulb. So 1 into 200 by 3. Okay, anyway, Isha, what is your answer finally? Which bulb glows brighter?
It's the one which have more volt.
Simply based on voltage, how can you say? It's not necessary that whichever has more voltage will glow brighter. No, you look at the rated values. If you give equal voltage to them, then also they are not glowing with equal brightness. This is different from this. How can you say that whichever has more voltage will definitely glow brighter? Now, for 200 volts, the second bulb will consume 100 watts. It would emit 100 watts also. We are assuming ideal bulbs. Okay. So if you supply 200 volts, B2 will emit 100, B1 will emit only 50. So B2 will be brighter. If equal voltage is given, the second one is brighter. If you give more voltage to the second one, it will glow even brighter, because for equal voltage itself, second one was giving more output. If you give an even higher share of voltage, it will definitely be the brighter one. But here you observe what is happening. The first bulb is getting a greater share than the second bulb. But simply because the first bulb is getting a greater share, we can't guarantee that it will glow brighter. Because with equal share, first bulb was dimmer. 200, first bulb emitted only 50 watts. Second bulb emitted 100. So even if this is given 250 volts, there's no guarantee that this will emit more than 100 watts or more than the second bulb. So there's another factor. No, simply based on voltage, you cannot tell. But you found the voltages that each bulb will get. You know their resistances and all. How to find out the power dissipated by each one of them? With voltage and resistance, how to calculate power dissipated?
V square.
V square by R. Okay, you can do that and tell and find out the power dissipated by each bulb. Fine. You can even tell the exact power each bulb would dissipate. All that is okay, but it's unnecessary to answer this question. I mean, all that is unnecessary to answer this question. You were just asked which bulb glows brighter. Now, how are the bulbs connected? Can any of you tell me?
Series.
Bulbs are resistors, okay? If they are connected in series, what is common to them?
Current.
Current is common. That's all. You could have made use of that. You can write power dissipated in terms of current and voltage, no? Okay. Or current and resistance. So P1 is to P2. You can write it as I square R1 is to I square R2. If they are in series, current is common. So the ratio of power dissipated becomes equal to the ratio of resistance. And which bulb and what is the ratio of their resistances? 2:1. So the power dissipated will also be in the ratio 2:1. The first bulb will emit more power, will consume more power, and we are assuming 100% efficiency, so it will emit more power in the form of light. Okay, the first bulb glows brighter. So, I mean, don't use only one formula V square by R. There are other ways also to calculate power or power ratios. Think of which formula makes it the easiest to solve. Since these are in series, current is common to them and it's a ratio based question. So you can write power in terms of current and the resistance. Okay. Suppose there is a 100 volt bulb, and there's a 50 watt 200 volt bulb. Assume the supply voltage is 300. Okay, initially the switch is open. So battery is still not driving current. Bulbs are still not glowing. I want you to comment on what happens immediately after the switch is closed.
The second bulb glows much brighter than the first.
Second bulb glows
Brighter than the first one.
brighter than the first one. How did you conclude that?
Like in the last question, I calculated the power.
Okay. But see, to glow, the bulb has to be safe also. I mean, you used the ideas in the last question, but in the last question, I asked you first, will both the bulbs operate safely or not? And we first decided whether they'll be safe or not. This is 200. Then the share that each bulb gets will be less than 200. So both of them are safe. But you observe this question. In the question, the given voltage, the supply voltage is 300. But the bulbs can only take 100 and 200. What's the guarantee that 300 will get distributed exactly as 100 and 200? What if one of them gets more than the rated value? You have to check that. Okay. Actually, in the exam, like in any entrance exam, by looking at the options, you'll get that idea, because in options they'll give B1 will fuse, B2 will fuse. Then you will get the idea that you have to check that also. Okay. But suppose this is board exam question, then you have to get that idea on your own. Anyway, check that first. Will the bulbs operate safely or not? Once you check that, once you are sure that they operate safely, then you can tell which will glow brighter and all. Can one of you tell me the procedure, how to check if both bulbs operate safely or not?
The second bulb
Second bulb
fuses.
fuses. Okay, let's see. So what you need to do is find out the share of voltage that each bulb gets just after the switch is closed. See, actually what happens, the moment we close this switch, current will start flowing everywhere in the circuit. It's not that current has to first go like this through the bulb B1, then through the bulb B2, and then reaches this side of the battery. It's not like that. The moment you close the switch, electric field gets set up and it starts driving electrons everywhere in the circuit. Okay. So there will be a current. As long as the circuit is not broken, there will be a current. So maybe just for a moment. there will be a current. If it's not broken, current will continue. If it's broken, the current will stop. Okay. So they will have equal currents, and when current passes through a resistance, voltage will get developed. So the moment the switch is closed, some voltage will be seen across the bulbs, both of them. Now, Shashank, tell me, since you seem to have done the calculation, what is the ratio of their resistances?
1:2.
1:2? Risha, tell me, what is the ratio of their resistances?
1:8.
It will be 1:8. Okay, V square by P. So 100 square by 100 is to 200 square by 50. Ratio of resistances is 1:8. So if you want to distribute the voltage, okay, it has to be in the ratio 1:8. 300 volt has to be distributed in the ratio 1:8, means you have to split it into 9 parts. One part goes to the first bulb. So 300 by 9 is the voltage that this bulb gets. And 8 parts go to the second bulb. 8 into 300 by 9. And 8 into 300 by 9, 8 into 300 is 2400, divided by 9 is definitely more than 200 volts. This 300 by 9 is less than 100 volts. But the other side, it is more than 200 volts. The rated voltage of the second bulb is only 200. The moment you close the switch, the voltage across it becomes more than 200. So what is going to happen to the second bulb?
It gets fused.
It gets fused. Okay, its filament gets broken. It gets fused. What will happen to the first bulb? Its rated voltage is 100. It is getting less than 100 the moment we close the switch. But later on, what happens to it?
It also gets fused.
Why will that bulb get fused?
Because once the second bulb gets fused, the connection is broken. There's no current flowing. So the first bulb gets all the 300.
No. What you said is partly correct. Once the second bulb gets fused, the connection is broken. The connection is broken means it becomes open circuit. Just a moment. It becomes something like this. Once that filament is cut, it's like this. How will the bulb B1 get any voltage now? The battery is not connected. The other terminal of the battery is not connected, right? When bulb B2 is intact, current has a path to flow. There is a closed path for the current to flow and it will flow. But when the filament of B2 is broken, okay, it's like the circuit is broken. Current will stop flowing immediately. Okay, and you won't see any voltage across the first bulb and no current. It won't even glow. You should not say it will get fused. It won't get fused. It simply won't glow. That's all. Okay, because current in the branch disappears, becomes zero. Like circuit gets broken, so the battery will not be able to drive electrons anymore. Okay, so if you connect this series combination to a 300 volt supply, based on the resistance ratio, we can tell that the second bulb gets a voltage of more than 200, voltage share of more than 200. So the moment you close the switch, it may glow for a nanosecond or something like that. For a brief amount of time, it may glow, but it will immediately get fused. After that, it will immediately get fused. The first bulb also, for an instant, it may glow, but then it will get turned off. Okay, fine. So 300 volt cannot, 300 volt is not safe for this circuit. Okay, it's too much for this circuit actually. Fine. Let us find out how much is safe for this circuit. What maximum voltage can be applied such that both bulbs glow without getting fused. They may glow brighter than their rated, not brighter, dimmer. They may glow dimmer than their rated values, but they should not get fused. So now that is the question. I'll erase all this. The values are given to you. What is the maximum supply voltage you can connect such that both bulbs operate safely? Think of an idea first, how you are going to calculate. Can any of you tell me an idea? How are you going to proceed with this? Okay. See, the question is to find out what maximum voltage can be applied such that both bulbs operate safely, no? So start by assuming some voltage. Let's say some voltage V is connected. When V is connected, you know the ratio of resistances 1:8. Okay. These are the same values from the previous question. Ratio of resistance is 1 is. So when a battery of voltage V is connected, you know how you have to split the voltages. So in terms of V, you can tell how much voltage the first bulb will get and how much voltage the second bulb will get. In terms of V, you can. Okay. So get V1 in terms of V, get V2 in terms of V, then write the condition that V1 should be less than 100 and V2 should be less than 200. From those you can find out the value of V. Try this, all of you. I got one answer as 225 volts. Maybe, we'll see. Okay, 225, you split in the ratio 1:8 means 9 parts. 225 by 9 is 25. Give 1 to this, 8 to that. Yeah, 225 is correct only. See, the ratio of voltages will be 1:8. Means totally you have to split it into 9 parts. And out of 9 parts, 1 part goes to this, so V by 9. And 8 parts go to this, so 8V by 9. So V1 is V by 9 and V2 is 8V by 9. The first bulb says that V by 9 should be less than 100. Means V should be less than 900. And the second bulb says, or for the second bulb to operate safely, 8V by 9 should be less than 200. Means 8V should be less than 200 into 9 is 1800. That means V should be less than 1800 by 8. Okay. Both bulbs have to operate safely, means both conditions must be satisfied. So it should be less than this and it should be less than this also. 1800 by 8. How much will that be? 225. Okay. So for the second bulb to operate safely, we should be less than 225. For the first bulb to operate safely, we should be less than 900. And we want both bulbs to operate safely. So we'll take the smaller of the two values. I mean, it should be less than 900. It should be less than 225 as well. Or equal to also, you can say. Yeah. So that way you can find out the maximum voltage that you can apply. Is the idea clear to all of you? Any doubts? Okay. You can be asked similar questions based on capacitors also. Now see what happens in a capacitor. We give equal and opposite charge to the plates, right? When you give equal and opposite charge, the plates have a tendency to attract each other. In fact, in case of a parallel plate capacitor, we even found out the force of attraction between them. So to keep the plates separated, we usually keep a dielectric between the plates. But dielectric, being an insulator, there is a maximum electric field that it can withstand. There's a maximum voltage that it can bear. Okay. When you apply too much voltage across a dielectric, the electric field becomes so strong that it rips the molecules inside the dielectric and it becomes a conductor. Dielectric is an insulator. Insulator becomes a conductor if you apply too much voltage. Okay, we discussed these examples of also lightning and all. So every dielectric has a maximum voltage that it can withstand, that is called the breakdown voltage. And because dielectric is being placed inside a capacitor will also have a rated voltage. It will have a maximum voltage that it can bear. If you supply more voltage than that, the dielectric between the plates of a capacitor becomes a conductor and the charges on the plates of the capacitor will combine. It will give out a spark. The positive and negative charge combine, it gives out a spark, in which in most cases damages the capacitor. Okay, so we should ensure that the capacitors don't get voltage more than the rated voltage. Okay, so let's try one question like that. Let's say this is a 2 microfarad 20 volt capacitor, and this is a 4 microfarad 10 volt capacitor. Okay, there could be a dielectric inside, whatever, doesn't matter. Capacitance is given to you, know, so even if dielectric is there, I mean, you don't even need to know what is the dielectric constant and all, even if it is there. The question is to find out what maximum voltage you can apply across this series. Such that both capacitors operate safely. Okay, you think of how to split voltages when capacitors are connected in series, split it and write the condition. Voltage across the first capacitor should be less than or equal to 20 volts. Across the second capacitor should be less than or equal to 10 volts. From that, you will get the answer. Solve it quickly, all of you. Okay, I got one answer as 30 volts. Let us check. Isha, can you tell how potentials will get distributed among capacitors connected in series?
So V1 is to V2 is equals to 1 by R1 is to 1 by R2.
1 by C1 is to 1 by C2, correct. Okay. So the ratio here will be V1 is to V2 is equal to 1 by 2 is to 1 by 4. That's 2 is to 1. Okay. So if you connect a voltage V here, battery of voltage V here, it gets split in the ratio 2 is to 1, means 2/3 across the first capacitor, 1/3 across the second capacitor. For the first capacitor to function safely, its share of voltage should be less than or equal to 20 volts. Means, okay, let's not write volts, it's slightly confusing. I'll just write the numerical value. Means V should be less than or equal to 30 for the first capacitor to be safe. For the second capacitor to be safe, its share of voltage should be less than or equal to 10. So the second capacitor also will be safe if V is less than or equal to 30. Therefore, 30 volts is the maximum voltage you can apply across this combination of capacitors. Okay. Isha, is this clear?
Yes, sir.
Okay. Let's try one more question like this with bulbs. Okay. B1 is rated, let's say 100 watt, 100 volt. B2 is rated 50 watt, 100 volt. B3 is rated 100 watt, 200 volt. Okay. Let's say the supply voltage is 300. First question is, like after the switch is closed, yeah. Okay. Find out what happens after the switch is closed. That means, do all the bulbs glow safely? If they do, which one glows the brightest? All those things you find out. Okay. Any answer? Fine. First, tell me the resistances of the bulbs. What is the resistance of B1?
100,
100 ohms. B2?
200.
B2 is not 200. P is V square by R is V square by P. 100 square by 50 becomes 400 ohms. And B3 also has a resistance of 400 ohms. Okay. 400 in parallel effectively become how much? What is
So
the
I
effect?
think B2 is 200.
The 100 square by 50, 200.
Okay, wait, just a moment. V square 100 into 100 divided by P. Okay, fine, 200. Correct. Sorry. Yeah. What about V3?
400.
Right. 200, 400. Fine. 200 and 400 in parallel effectively become two resistors in parallel. You can use R1, R2 by R1 plus R2.
400.
That is 8 by 6, 4 by 3, 400 by 3. Okay. So one resistance is 100 ohms. The resistance of the combination of B2 and B3 is 400 by 3 ohms. Okay. 100 ohms and 400 by 3, they are in series, and that series is connected to the battery. Fine. So from this, you can distribute the voltages now. 100, 400 by 3, what is the ratio? 3 is to 4. Multiply 3, 300. 3 is to 4. Okay. So the 300 volts gets distributed in the ratio 3 is to 4. Means the first bulb B1 gets a voltage of, okay, I'll write it on the lower side. B1 gets a voltage of 3 parts out of 7. So 3 by 7 of 300. That's like 900 by 7. And B2 and B3 together, they're in parallel, no, they'll get a common voltage. B2, B3 combination gets a voltage of 4 parts, 4 by 7 of 300. That is 1200 by 7. Okay. Now if B1 gets 900 by 7 volts, will it operate safely? B1's rated voltage was 100.
No.
900 by 7 is more than 100. So B1 will get fused. The moment you close the switch, B1 will get fused. What about B2, B3? Are both of them safe?
So current will not pass.
Current, why will current not pass through them?
Because this got fused.
But see, you are again imagining it the wrong way. You are thinking that current first goes through this resistor, then it goes through the other resistor. It's not like that. Current gets established in the circuit everywhere at once. Okay, the moment you close the switch, you will see current flowing everywhere. But if that current is too much, then fusing will take place, and fusing can happen at multiple places at once. Current will get established everywhere. Okay, so we found out their share of voltage. No, that share of voltage will get established. It's not like it will go one by one. So tell me, are B2 and B3 safe? B2's rated voltage is 100. How much voltage is B2 getting after closing the switch? 1200 by 7. 1200 by 7 is more than 100. Okay. So is B2 safe or will it get fused? It will get fused. B3 is safe because it gets a voltage of 1200 by 7, but its rated value is 200. 1200 by 7 is less than 200. So B3 is safe, but because B1 got fused, B3 cannot glow because current needs a closed path to flow. You can't have current flowing only through this bulb and like this. You need a complete closed path. Once B1 gets fused, it becomes open here. The circuit becomes open here. B2 gets fused, the circuit becomes open here. Now there's no closed path for the current to flow through B3. So it will not get fused, but it won't glow also. That is what will happen. Okay, is this clear? Any questions in this? Questions or doubts?
So once
Hmm.
the B1 get fused, will the B2 glow?
Isha, again, you're asking the same. It's not like B1 gets fused first. It's not like that. These voltages that we found out, 900 by 7 and 1200 by 7, they will get established together at the same time. Okay. So the moment you close the switch, you will see a voltage of 900 by 7 across B1, and you will see a voltage of 1200 by 7 across B2. And this voltage is too much for B1, it will get fused. This voltage is too much for B2, it will also get fused at the same time.
Yes.
Okay. Huh. But I understand your question. Let us try to frame one question like that. So in this situation itself, shall we increase the rated voltage of B1? If you increase rated voltage, you'll have to calculate the share, the distribution again. Let's try. So what we are going to try now is we are going to keep B1 safe for the first instant. Okay. And then check what happens. So let's take some values. Okay, we'll increase its we took 100 watt, 100 volts, no? Okay, fine. Let's take fine 400 watts, 200 volts, B2, B2. Let's take same as the previous question, 50, 100. B3 also let us take same as the previous question. Let's see what happens. Okay, tell me what happens after the switch is closed. Same 300 volt is connected. Try. Any answer? How much are the resistances this time?
They're the same.
Same. If it's the same, then okay, let's see.
But this time B1 doesn't fuse.
Okay, 100. This was 200 ohms. And this was 400 ohms. 200, 400 together becomes 400 by 3. Ratio 3:4. Then B1 gets a voltage of 900 by 7 volts. The moment you close the switch, it will get 900 by 7 volts. B2, B3 combination gets a voltage of 1200 by 7 volts. That's immediately after closing the switch. Now, B1's rated voltage now is 200. 900 by 7 is less than that. So B1 is safe. B2, it gets 1200 by 7, but it can only bear, it can only take up to 100 volts. So this will fuse. What about B3? B3 can bear up to 200. It's only, so this is also safe. Fine. So the moment we close the switch, this is what happens. B2 is fused. What happens next? Will B1, B3 continue glowing like that? Will they continue getting those voltages 900 by 7 and 1200 by 7? Or will there be another distribution?
Analogy.
Now the voltage will get distributed again, because the moment B2 gets fused, it becomes a different circuit. It becomes a different network. So we are sure that B2 will get fused right after we close the switch. What happens next is what we need to find out. So now B2 is not part of the network at all. So you can remove this wire altogether. The 200 ohm is no longer present. So these are the resistances now. 100 and 400, ratio 4:1. Sorry, 1:4. Now you have to split 300 volts in the ratio 1:4, means 5 parts. One part to this, 300 by 5 is 60 volts. 4 parts to this, 240 volts. Now tell me what will happen. Their rated voltages were 200 and 200.
B3.
B3 will fuse now. And B1 will stop glowing, because the moment B3 fuses, there is no path for current to flow. Okay, there's no closed path for current to flow. B1 will stop glowing. It won't fuse. Its rated voltage was 200, but it gets only 60, so nothing will happen to it. So now you can say B2 fuses first, followed by B3. Okay, but anyway, the time difference will be negligible only. It will almost happen almost immediately. Both will fuse almost at the same time. Okay. But if they precisely ask you which fuses first, you can tell it is B2. The time gap is negligible actually. But yeah, one happens before the other. Is this clear to all of you?
Yes, sir.
Okay. Okay. Fine. Next thing I wanted to discuss is meter bridge, but since many of the other students have not joined, we'll do it in the next class itself. So today what we discussed was bulbs and networks of bulbs, how to ensure they operate safely. Okay. If a certain amount of voltage is supplied, what is the brightness of each bulb, which glows brighter, which glows dimmer, you can find out. To a certain network, you can tell what is the maximum safe voltage that can be applied. Okay. We applied that to capacitors as well. Okay. Right. So next class we will discuss about meter bridge. Next class will be on Monday itself. Okay, not Tuesday. We'll have class on Monday. And tomorrow I'll send you a worksheet based on these bulb and capacitor questions you can solve. So if you have any doubts or questions, you can ask. Otherwise, we'll continue on Monday.